just like to introduce Rob Anderson, who's data insights, data scientist and AI expert, and he comes to the stage with a master's and first class honours in data science from Auckland University, you just done your PhD papers? Has just submitted his thesis. So Rob brings that unique combination of practical commercial business experience, and he really knows how to make the complicated simple to help organizations develop AI systems that drive value. So please, welcome to the stage, Rob Anderson.
Thanks for that introduction, Justin. If we only have 10% of our brain power at this time of the day, and we're talking about AI, I'm going to have to make the complex really simple. So I'm going to talk about accelerating your business using AI, finding the right projects that AI can provide value from in your business. So I'm going to start off by talking about what AI is. Why does it matter now? I'm going to move on to taking some homegrown examples of AI from New Zealand, examples that our neighbours are doing, rather than that are coming out of Silicon Valley. Finally, I'm going to talk about being ready for AI. What are the secrets to success that we've seen when we've worked with our clients on AI projects? But first of all, what is AI? Well, we all learnt what AI was from the movies we saw. Terminator, Bicentennial Man, AI, Ex Machina, and we see these robots that can walk around, talk, and feel. So when we think about using AI in our business, it's a bit confusing. These are, in academia, these are called general AI, AIs that can learn to do anything and can learn one thing and then use those skills to learn something else. In businesses, we talk about functional AI. You build an AI to fulfill one function. And when you think about AI in your business, you need to think about what function you're fulfilling. This is all AI is, by my definition. Some sort of automated decision-making, and perhaps some automated actions as well. Going for a really simple example, we've got a churn model. What this model does is it makes a decision based on a customer's traits to decide whether that customer's likely to stop buying from us or not. So sometimes we have some automated actions as well. The churn model might just give a probability to a staff member who can then call up and persuade our customer to stay with us. But perhaps instead we've got a lineman working on a network who takes a photo of an installation. And if that installation is faulty, we might automatically order a repair through that photograph showing there's an issue with the install. So sometimes we have those automated actions, but not always. So this is another way to look at AI. Pretty much you have some inputs, you make a decision about them, and you have an output. Let's think of topic modeling, for instance, using natural language processing. You might input a set of Net Promoter Score surveys, and it will decide what the relevant topics are and pull them out. Or you might have sentiment analysis on the same surveys. Who's happy and who's sad and with our services, and who are they? Or like the example I was given before, you might actually have some other output being an order to the repair person to come and actually fix a faulty installation. What's machine learning when you talk about artificial intelligence? Once again, keeping it really, really simple, machine learning is what we do to learn the automated decision making. It's a process normally where we take a whole lot of example data and we summarize it in a useful way into an automated decision-making tool. So what's changed with AI? Neural networks were invented in the 60s. Deep Blue beat the top chess champion of the world in the 80s, but only now have we really been talking about AI solutions. Why is that? Well, first of all, data. We all have so much more data now from our business. So storage increased in a big way from the 80s. That's when relational databases were invented. And we've all been collecting this information about our business, about our organizations for decades now. We have this really rich resource with a whole lot of insights hidden within it, showing what drives our customers, who our customers are, or what we need to do to meet our customer needs better. We've got the processing power to do it now. We've got the technology. Every phone in your pocket has more processing power than the computing systems that put the lander on the moon. with that sort of processing power, we're able to take a whole different approach to learning from data. In the past, statisticians would take one hypothesis and test it against a data set. Now machine learning models, some actually look at the data from every single possible angle and try and find that angle that shows that hidden truth within there we wouldn't find otherwise. The tools. So, if you worked in what was machine learning back in the 90s or statistical modeling, you'd probably use SAS, SPSS, and MATLAB. One of these tools, which had huge licensing fees, and the first time you'd actually ever see it was when you were in a job that required it. They'd pay huge amounts to train you for it, and then you'd be ready to do your job. Not many people knew how to use these. But now, pretty much everyone who goes through Auckland University comes out with a knowledge of R or Python if they're doing any business-related course. So they've got the tools to implement AI solutions, and they're keen to implement these solutions as well. We've got a much wider coverage of people who can implement AI in your business. And now the last one, and a very big one. People have been talking about disruptors in our industry for a long time. Since the 90s, we've seen Google revolutionize search, we've seen Uber revolutionize taxi services, we've seen Airbnb revolutionize accommodation booking. So where this leaves the rest of us in other industries is actual worry that someone's going to come along and upend us. Amazon's going to come along and knock us away if we're a large book seller. The problem is we don't know who's going to come and how they're going to compete with us using this new technology. That's why a lot of businesses are really keen to have that literacy of AI, that knowledge of machine learning, so they can be prepared for when that moment comes. I was talking at a life insurance conference a couple of years ago, and something quite interesting there was everyone's aware of Fitbits. And there's this possibility of giving you discounts based on regularly exercising in life insurance. Most life insurance companies have discussed this possibility, and they're just waiting for the first mover to actually have a go at changing the charging to see how it goes. They've already prepared for an innovation that they haven't implemented yet. So there's a lot of protection from trying to protect yourself from future disruptive forces. So what can it do? Well, let's talk about some Kiwi examples, what we're doing right here, and how people are adding value to their businesses using AI. So I'm going to start off talking about a couple of really simple example and move to the more complex, amazing, dare I say, magical examples of AI that are out there. So Xero. Lots of people enter lines into Xero about their costs, expenses. In the past, they've had to enter their account codes for every cost line they put in. What's the problem with this? Well, it takes a lot of time and people make mistakes. They created an AI. You wouldn't even know an AI was running unless you were an informed customer. Pretty much all it did, when you entered a line, it would have learnt from your previous invoices and it would auto-populate the account code. Really simple, really small, the customer doesn't even see it. We're not changing the world here. But what that actually leads to is reduced errors and improved user satisfaction. It means that customers have an easier experience and there's going to be fewer errors in our data set. What this means is that Xero's resource, their data, is actually cleaned as it comes in. So they're actually winning while their customers feel happy too. And this is off a really simple little implementation. Not a difficult problem. Apparently, their first attempt had correct suggestions 80% of the time after just 4 invoices. Very easy to solve problem, and the change it makes over years will be absolutely huge. So creating resilient models. Our partner, Velocity, has a very accurate property valuation model that they've developed over many years, and we wanted to see if we could make it more resilient. So currently it uses a range of data, and especially about recent sales. And what we tried to do was introduce more variables and wider variables, and using sales from other areas to also approximate prices. What this helps do is future-proof this model. So where you have times of low sales, where sales dip, we'll still be able to use wider data to accurately predict prices of properties in those areas. Obviously, banks are making lending decisions worth millions every day. So the quality of this information is really important. By future-proofing this solution, we managed to broaden the set of prediction tools Velocity can use, so they have that extra option for properties they know might be difficult. We improved runtime by 50 times, because machine learning models can be very compact representations of a lot of knowledge at once. And the valuation model's now more resilient to changes in the market in the future. One of our other partners, who were trying to predict unseen behaviors, was Chorus. So we all know about fiber. Probably most people in this room have fiber. But Chorus have faced this challenge of predicting demand in new areas when they launch fiber. They had a whole new phase of fiber that they were launching in a lot of areas which were quite different from the existing cities and towns that had fiber. So what we could help do is actually generalize the demand that we'd seen in those similar, that we'd seen in cities and towns that already launched in. And based on similarities with the new towns they were rolling out fiber in, we'd be able to predict what demand looked like. So we managed to predict orders within 10% accuracy 3 months in advance for new areas. We could predict at the neighborhood level or the regional level. And by providing these long-term forecasts, we could inform their strategy, helping them decide where they were going to launch first and what they'd expect to see once they had launched. So something a little different. Imager, a Kiwi startup, has sought to transform day-to-day life with a smart shopping cart they've created, called, funnily enough, the Smart Cart. So what this does is it's got a camera in it. As you take goods off the shelf and put them into the cart, it uses computer vision to decide what you put in there. So you've got a camera here, you see the goods as you put them in, and you automatically get a shopping list populated. Now, you can walk straight out the store with your goods, you'll be charged automatically, and there'll be no supermarket queue you're stuck in. From their research, they thought 58% of customers would change supermarket if a supermarket offered this service. And they've actually run a successful proof of concept trial at Foursquare Ellerslie. So what this provides, this is transformational. This completely changes something we do on a day-to-day basis. And imagine how much time you can save for customers by changing how shopping works. You know, something we all do at least every week, probably. So something else that's happened for Imager is that they're in discussions with 3 large supermarket chains in Australia, the US, and the UK, which is really impressive. A little bit of Kiwi ingenuity making a difference in the world. Now, probably one of the most impressive AI implementations I've ever seen, let alone in New Zealand, is BabyX by Soul Machines. So what they've sought to do is simulate the human experience. They've taken a whole lot of academic models based around different biological systems that were previously separate, and they've joined them together to try and create a simulation of a living, breathing human. So let's see what that looks like.
Meet BabyX.
This is BabyX, so she's basically an autonomously animated virtual infant. All of her behaviours are generated on the fly by neural networks running live, and so she's seeing me and listening to me and responding to what I do. So she's going to start wondering what I'm doing and starting to get upset because I'm not paying attention to her. So I need to calm her down, but I have to talk to her like a real baby. It's okay. Hey.
BabyX is driven by a virtual nervous system. So let's take a look at what that actually means.
What we're looking at here is BabyX's virtual anatomy, which is all controlled by her virtual nervous system. So that's controlling everything that she's looking at, all of her expressions. It's even controlling her breathing rate and her heartbeat. We can make it more transparent, and we can zoom out and see the whole model. All of the motion that you're looking at is controlled essentially by her brain model, which is driving her limbs, her facial expressions. We can see the facial nerves through here. Let's take another level deeper, and you can see her virtual brain model here. You see the brain stem, which is basically responding to all kinds of sensory input, and it's affecting the attention of the model.
So what they've done is used an assembly of models together to actually simulate what a living, breathing human looks like, and used for computer vision and microphone on a computer so that it can respond to people talking to it. So we've found a commercial use for this, and that's through providing simulated human virtual assistants, which are being rolled out in New Zealand as we speak. A really exciting other possibility through using these virtual assistants is the ability to personalize customer interaction. And they've actually kicked off a project in Australia, providing an interface for people with learning disabilities to have a conversation they're more comfortable with. So that's really good personalization of your service for your customer. And finally, they've created high-quality, repeatable processes. So what this means is that you can go online in the middle of the night and get the same sort of service you get in the middle of the day. So there's some really interesting implementations to this. But that's the business side of things. I saw Mark Sager talk at an academic conference, and he showed the latest BabyX model at the time. And he showed, for instance, he could tweak the amount of dopamine in the brain. And he actually showed the symptoms of Parkinson's by decreasing the dopamine that was affecting this baby's system. So I don't know how much any of you have heard about the virtual self. It's a medical concept where if you can create a useful enough simulation of someone, perhaps who has a complicated case of cancer or something like that, you can then test how different medications would impact that person, and you can see what medications would likely work well and what would not. I think it's still fairly pie in the sky, but we're getting there. There's a saying that any technology sophisticated enough is indistinguishable from magic. And certainly if any of us went out to create BabyX today, we probably wouldn't know where to start. But something that's really worth remembering when you're looking at presentations, especially from Silicon Valley, but even something like this. This is iteration 20, this is iteration 50, this is 3 decades down the road of an initial idea and initial research. And when you're starting an AI project, often you're starting on step 1. You might have a bit of prior knowledge, but you're not trying to transform the world. You're trying to find something useful to change your business and provide extra value to customers in a useful way. So when people want to talk to Data Insight about AI, this is a normal conversation we have with them, and I'll share it with you today. We want to know where they are on their data-driven journey. With our clients, we have people with sophisticated database systems. Sometimes we have to learn on the fly because they're so new. And sometimes they come to us with a few spreadsheets cobbled together, and half of one of them's missing because the system stopped writing after midnight. So we want to check whether you, our clients, have your data foundations in place. Do you know what information you have, how it joins together, what fields are missing, and what the fields mean? Have you done a data audit to truly understand what you've got and its strengths and weaknesses? Do you do reporting and dashboarding on your data? Do you get day-to-day updates from the data that's coming in on the health of your business? And can you check how business is running from reports and dashboards you've got available? Have you moved on to deep diving, profiling and analysis, where you really interrogate your data, asking what drives your business, who your customers are, where they are, why they come to you? Have you moved on to modeling and advanced analytics? Do you do A/B testing, segmentation, market basket analysis, all of these quite complex statistically based approaches to find out things about your data that you wouldn't be able to on a pivot table? And finally, have you moved on to machine learning and AI? And if you haven't and you've done everything else, perhaps you're ready to. So we're not trying to make AI a gated community or anything like that. Anyone can have a crack. But what we really find is that if you want bang for your buck, skipping some of these steps means that you miss these opportunities to learn about your data. When you're making dashboards, when you're profiling, you figure out where your data misbehaves or where it acts a bit different from what you expect. And when you're building a machine learning model, it won't be nearly as transparent when that issue is actually causing some sort of mistake in the modeling. So what we find is that companies starting along their journey will benefit from these first stages more than the later stages. And once you've got your data sorted out, you've seen the value and benefit you can get from simpler techniques, then you're ready to have a crack at using machine learning and AI to solve your problem. I've worked on a few AI projects in my time with some of our clients and partners, and what I want to tell you now is about the key factors I've seen that decides whether, at the end of the day, an AI project's been successful or not. First of all, a problem that needs solving. Lots of companies say, let's do AI. Oh, we've always wondered about whether we can use this data to get an answer on this. That's not the best use for it, I find. You know why? Because that's not part of your regular business process. If that is so important to do, so important to achieve, solving that little question out to the side, why is it not already being done? Instead, what you should be doing is looking at the business processes you really know and understand and say, can we get better value from improving on these processes? What you also need is that clear scope. How much do we need to do to get that value? And when do we say, right, that'll do, let's stop and let's review what we've done? So the other side of this coin is will and belief. Another word I like to use, commitment. At Data Insight, we've got an advantage over your internal data science teams because when our partners and clients come to us, they already have they have agreement within their business to make a change and use AI for that solution. Their stakeholders have come together, agreed it's the right path, and put money aside to actually implement these solutions. So one of the challenges internal teams have is that someone says, why don't you have a crack at that? And they get onto it, and they have a go, and no one ever adopts their solution. I wonder how many great solutions are sitting in lost folders on shared drives because, people did some good work, but the rest of the organization wasn't ready to commit to it and actually try to see whether it delivered value. And agreed business cases, I think that you should get some sort of commitment in terms of normally some sort of financial commitment, even from your internal teams, if they're asking for something with AI. Otherwise, you're in danger of having another orphan project, and people in the future will say, oh, let's not try AI again. Well, the truth is that you never really tried AI in the first place when that happens. So the data and tools. How well do you think I'd do if I went out and tried to predict what was happening on the stock market with weather reports, no matter how accurate they were? I might do okay, but everyone else has got that information, and we're not going to really be able to solve the problem in any meaningful way. If you're tackling a problem with AI, hopefully the answer's already in your data somewhere. It might be hidden away. It might require a complex analysis to find. But what you will have seen through the earlier steps of dashboarding and profiling is that you'll see that there's something there, that the variables you're using can help answer a business problem. And you'll have the faith that AI can deliver a solution with that data. Also, you need flexibility and capability. So a lot of people are hamstrung by their tools when they're doing data science projects. For instance, if you try to do something in Alteryx, which is a great tool that can do a bit of everything, what you won't be able to do is get the really customized, the great customized, fit-for-purpose model, machine learning models that'll solve your problem. At a certain point, you're not allowed to make any more changes. You've reached the limit of what it can do. So you give your team a huge advantage if you let them have a suite of tools. And we'll talk a bit more about that on the next slide. Finally, having the right team. So machine learning projects and AI projects tend to be very iterative. So a normal profiling and analysis project, any experienced analyst can make a decent prediction about how long it will take to complete. With machine learning projects, you can predict how long it will take to build the first model. You're not quite sure how well it will do, and you're certainly not sure how many iterations you'll need to hit that minimum viable product level. Now, what experience lets you do is it gives someone, it allows there to be someone on the team who can ask the right questions, find the next direction after the first iteration hasn't worked, and use their knowledge from normally prior failed projects, to be honest, to make sure that this one gets to the right solution faster. It's also really important that you have diversity on your team. So a diversity of skills is very important, but also a diversity of viewpoints and backgrounds. Too often, especially with machine learning and AI and projects, you've got one person who's got a great set of skills and, they're very capable, and so they're left to build the model. What they don't have is someone to challenge them, ask about tackle the model in different ways. Say, does a model really work if we strip away that assumption, if that assumption won't always hold in the business? You might even have the danger of having a bias in your model. So a very good, simple example of an issue currently facing a lot of machine learning, the field as a whole, is that it tends to be biased by past data. And a really easy example of how you could build bias into past data is if you take, promotion data at a large organization and you use it back to the 50s, you may find that generally beyond a certain point, older white men would be more likely to promoted into higher roles than any other group. Now, if you use that data, more data is good data, that's what we say, but sometimes you introduce bias from your data, bias you don't actually want in your model, by using more data. And so, once again, just having a range of people on the project who can challenge it and ask the right questions about what the model is doing is really important. Finally, make sure you've got an organization-wide awareness of people with data science skills. Use Yammer, use Slack, use Microsoft Teams. Make sure people have a way to talk to each other. So when you're designing an ML solution, you come up with your idea, you think it looks good, and you present it to partners who often, if they're not experts, they might not necessarily know the right questions to ask. But if you've got a wider team around, or your internal client, but if you've got a wider team around you that you can have challenge you, that you can point out things, then you're much more likely to build a better model, and also you can ask them about how they'd do it. So this dovetails nicely into my next slide, where I've summarized data science. What is data science? There you go, here it is. If I try putting that up on LinkedIn, I'm sure I'd get challenged, but this is a definition of data science I've come up with for this presentation. So you've got skills around building a platform, you've got skills around building data ingestion and feature engineering, you've got skills around learning from the data, and you've got skills around presenting that data. Now, people have heard of a unicorn data scientist, and often when a data scientist applies for a role, they might say they've got a little bit of everything. They might have a little bit of everything, but they're not going to be that good at a lot of it. So, if someone's an expert in cloud architecture, it's a bit unrealistic to expect them to be an expert at dashboarding. And if someone's a statistical modeler, they probably don't have a huge knowledge of database management. Part of the difficulty when you hire a data scientist is there's the expectation that they can cover all bases. But also, think about your tools in terms of this. If you're relying on SQL to do absolutely everything here, it's fantastic with getting in data. You can do some reasonable feature engineering. If you're really clever, you can implement some machine learning models in there. A bit hard to train them, but you're not going to get much presentation. Something like Tableau, though it can do a bit of all of this, it will have weaknesses that other tools don't. So this is why it's important to make sure you've got a range of tools available for your staff working on these problems. If you want to think about artificial intelligence, my definition of it is that it's involved in the data ingestion, how clean the data is, how the features are engineered, and how we learn off those features. But an AI project isn't going to be successful without the right platform for it to do its learning on. And it's not going to be successful without a useful way to present the information back to the end users. And so when you start an AI project, think about what skills you need. And just because someone's called a data scientist, don't assume they've got all of this at their disposal. So the last thing I want to talk about before I finish up my talk is the AI trade-off. When you choose a machine learning approach or an AI approach, normally you're trading off one benefit for others. You want a really accurate model that can predict exactly what's going to happen in the next Football World Cup. Well, you might go deep learning and go black boxes, a black box approach like deep learning. And perhaps you train it long enough, you spend the time building these models that can take literally weeks to build, and you might have something perfect. You're not going to be able to understand what it's doing, though, what logic it's using to decide who wins what match. And it takes a lot of time to build that model. If you want something interpretable, you're not going to be able to use those black box techniques as easily. You're going to have to find different techniques that you can actually see what weight they put on each feature and what transformation they're doing to make a decision. It will also take a lot of time because you'll have to check that you understand that using examples to make sure that you properly understand what that model's doing. And if you want something fast or out of the box, it can be cheap and it can run quickly, but you probably won't know what it's going to be doing, and you probably won't be getting great accuracy compared to even simpler approaches. So I'm going to finish up the talk by saying that when you're running an AI project, always ask yourself, what's your priority in terms of that trade-off? Do you need to be able to explain the decisions your model makes? Do you need something really accurate? Or do you need something fast, cheap, now? And to be honest, if you want something fast, cheap, and now, normally I'd suggest you double-check that because it might not always perform like you want it to. What does success look like? So this isn't necessarily how good does it have to be? Because the problem with that is people think that you'd also be happy with better. People like me love fiddling around with machine learning models, trying to improve the evaluation, a particular metric we're using to evaluate it. And you can leave a lot of data scientists quite happy in their lab tweaking away till they get what they think is perfect, which will never actually happen. So it's important to have that cutoff point. What delivers value? Once you reach that point, right, let's launch it, and let's see how it goes, and let's decide if we want to revisit it soon, once we've reviewed what it currently does. And finally, but not the least important point of my talk at all, does this pass a headline test? So we're custodians of our customers' data. They trust us to use it responsibly. And if the front page of a New Zealand Herald tomorrow says that your organization is using this customer data to make this decision, how will it reflect on you? Will you be able to turn up at work the next day? Will people make a comment about where you're working? It's really important to think about this headline test when you decide to do something, to decide, is that a proportional use of data? Am I using the data responsibly? Or could I use something more aggregated, more approximate to achieve the end goal we're aiming for? The last thing I'd say is, what value can AI provide your customers? Thanks for coming to listen to me.